Using derivatives of sine and cosine, this lesson will focus on increase and decrease and critical points and maximum minimum. So I have a couple of examples for you. And remember, if we're looking for areas of increase and decrease, we have to find the first derivative. So the first derivative for y equals cosine 2x, you have to keep in the back of your mind what the curves look like, what the sine curve looks like, and what the cosine curve look like. So maybe you want to have them sketched on a sheet of paper. And notice that the interval in this question goes from negative pi to pi. So the derivative of cosine 2x is negative sine 2x times the derivative of what's inside, which is 2. So with multiplication, I can move the 2 to the front. The derivative equals negative 2 sine 2x. So I'll be looking at the sine curve. And I notice that the 2 in front of the x, that's what affects the period. So if I'm looking at where the sine curve equals 0, the sine curve equals 0 at 0, pi, and 2 pi. And also negative pi if I went into the other direction. So with the 2 in front of the x, that changes the period. So I need to divide all those where x equals 0 by 2. And I make a wriggle graph to kind of plot what I'm doing. And I've plotted it from negative pi to pi. And since for sine 2x equals 0, where does it equal 0? At negative pi over 2, 0, and pi over 2. So the intervals in between that, remember pi over 2 is like 90 degrees. So what's in between that? What are the checkpoints that I'm going to use? Are negative pi over 4, 3 pi over 4, and negative 3 pi over 4. And I'm going to sub those into the first derivative. You can also sketch this on your graphing calculator. And if you put this in on your graphing calculator, you can use the table feature on your calculator, and you set up that you're the user on your calculator, and then you can see, hey, just by the numbers, where the area of increase and decrease occur. So you can see that on the wriggle graph, I have identified by the plus and the minus where the increase and decrease occur. And if you take a look at it in your graphing calculator, you'll also be able to see. So the area of increase, according to my wriggle graph, as well as my graph, is negative pi over 2 to 0, from pi over 2 to pi. And where is it negative? So where does it decrease? From negative pi to negative pi over 2, and 0 to pi over 2. So you should be able to, on your wriggle graph, be able to kind of sketch what the curve looks like. And with the sketch of your curve, you'll then be able to determine what the maximum and minimum points are. So with the maximum and minimum points, remember that you're going to substitute the values into the original equation. So I'm going to substitute negative pi over 2 into the original equation, and I'm going to substitute 0 into the original equation and pi over 2 into the original equation to find out where my maximum and minimum points are. So at x equals 0, I sub in 0 into the original. So cosine of 0 equals 1. So my ordered pair is 0, 1. If I substitute in negative pi over 2, I have cosine negative pi. So my y value is -1. So that is a minimum point. And if I substitute in pi over 2, I get the cosine of pi, and the cosine of pi equals -1. So you should be able to now, from your graph, from the work that you've done, you've been able to sketch a curve noting the increase, decrease, critical points, the max and the min. And you've done this work before, so it should be familiar to you, but let's try another example. So in this example, it's asking you to determine the concavity and the inflection point for y equals sine x cosine x. So the first thing I need to do is I'll have to find the first derivative. And since I want concavity and the inflection point, that requires me to take the second derivative. And then I'll need to determine the zeros of the second derivative to determine, hey, where is it concave up, where is it concave down, and what the inflection point is. So in order to determine the inflection point, remember that I'll have to make the second derivative equal 0. So we're just going to work through this. So first step first, I have to take the derivative of y equals sine x cosine x, and I'll need to use the product rule here. So the derivative, I leave the first term, so leave sine x. Derivative of cosine x is negative sine x plus, leave the second part, which is cosine x, and the derivative of sine x is cosine x. So once I combine these, remember sine x times sine x is sine squared x, and the first term is negative, and cosine x times cosine x is cosine squared x. So just remember those. I've written that on the side as well, that sine squared x is the same thing as sine x all squared, and cosine squared x is the same thing as cosine x all squared. So now I need to take the second derivative, and I'll need to keep this information in mind because I will use the power rule to find the second derivative. So the derivative of negative sine x all squared, so the 2 comes out front, so -2 sine x, and it would be to the exponent 1, times the derivative of what's inside, and the derivative of sine x is cosine x, plus, so cosine x all squared, the 2 comes in front, so I get 2 times cosine x, times the derivative of cosine x, which is negative sine x. And I'll need to simplify the right-hand side of this equation because plus 2 times a negative will make that -2 sine x cosine x. So here's my second derivative, -2 sine x cosine x -2 sine x cosine x. I can combine like terms to make -4 sine x cosine x. And if I factor out a -2, I can also make it 2 sine x cosine x, and 2 sine x cosine x is sine 2x. Now I need to determine the zeros of the second derivative. So that means that I'll have to make the second derivative equal 0. So 0 equals -2 sine 2x, divide by negative 2 to both sides. And my period is from 0 to pi. Because remember, it's 2 pi over k. K in this case is 2. So I sketch the sine curve from 0 to pi. And where does sine 2x equal 0? It equals 0 at 0, pi over 2, and pi. So for concavity, you can see from the sketch that I've drawn on my wriggle graph, you can see the concave down from 0 to pi over 2, and concave up from pi over 2 to pi. And my inflection point is there at pi over 2, 0.